All right, I'm going to go through how to calculate the relative atomic mass of a certain element, and hopefully this will help you guys. Um, the stuff up here we're going to save for a little bit, so that's some isotopes of lithium, and we'll go through that soon. But to start off, I want to talk about grade point average. Okay, so hopefully this will help give you an example. So this is how your grade works and your GPA, if you're wondering. You get grades A, B, C, D, and F in high school. And let's say you've taken, I think this is 10 classes. So you've gotten 5 A's, 2 B's, 2 C's, 1 D, and no F's. And you want to know, what's my GPA? Now, we're going to calculate it like your counselor would, or like what's done on your transcript. We're also going to do it in kind of a chemist notation and talk about percent abundance. Okay, but for now, here's how GPA works: is you'd multiply the number of A's you got times 4, because it's 4.0, it's that A, and then you do that for B's, C's, D's, and F's. D's are worth 1.0, F's are worth 0. So here's what you do. You'd say 5 times 4, well, that's 20. And 2 times 3, that's 6. 2 times 2 is 4. 1 times 1 is 1. And then we've got 0, of course. You add them all up, that's 31, I think. And you add up how many classes you've taken, that's 5. This is how many credits, so maybe 5, 9, 10. 10 total credits. And so you take your 31 points over 10 credits, and you get an average of 3.1 GPA. Okay, so that's the typical GPA calculation. Now, that's pretty much the same for how a chemist would do it, except for, switch to this, they like to talk in things called percent abundance. So to calculate percent abundance, we still need to know the total number of classes you've taken, which is still 10. Okay, but then to calculate percent abundance, what they do is they look at, out of the 10 classes, how many A's? Well, that would be 5 out of 10, or 50%, or written as a decimal, that's 0.5. Okay, and I'm just going to keep two digits here, two significant digits. I know it's actually infinite, right? Because 5 classes or 5 A's out of 10, we know that you got exactly 5 out of 10, but we're going to just do GPA down to the hundredths. So for this example, that's kind of how we're dealing with our precision. And so same thing, they'd say 2 out of 10 classes, or 20%, you got B's. Well, that's the same for C's. And I think 1 out of 10, right? That's 10%. And then the other one is 0%. Now, if you notice, you add up all the percentages, 50%, 20%, 20%, 10%. Of course, it's got to add up to 100%. Okay, and so that's all 100% of your 10 classes, just written as percent abundances. So 0.5, 0.2, 0.2, and 0.1. Okay, so nothing special there. But then what basically a chemist would do to find the average GPA, they're going to take the percent abundance times the points. So they're going to take a point for an A, right? And they're going to multiply it by the percent plus the points for a B, and multiply it by the percents plus, and on and on and on. They're going to do it for all grades. Okay, so what that ends up looking like is, well, so for A, it was 4.0 times 0.5 plus 3.0 times 0.2. Oops, I'm going to throw in some sig figs. Plus 2.0 times 0.2 plus 1.0 times 0.1. Think, and then plus, we don't need to include the 0, right? We've already accounted for all 100%. The F's don't count in this case because there was none of them. So basically it's a point times a percent, point times a percent, point times a percent, point times a percent. Okay, that's called a weighted average. Okay, and we can calculate it out. That comes out to 2.0. I'm just going to go to the hundreds. I know this isn't sig fig rules. This comes out to, what do we got? Point 0.6. Comes out to 0.4. Oops. And this comes out to what do we got? 0.1. So then when we add it all together, I think we get 2.63, 3.1. Okay. Now you're thinking, oh, Mr. Ford, that's a lot. I don't need to change them all to percents and then do this multiplication. But basically, that's what you are doing when you do something like this. So let me just write it out. I only need to show you guys this once, and then we'll just do it the typical way. This was how you guys averaged it, how the counselors averaged it at first, right? They multiplied all the points by how many grades, then they added the points together, then they divided by the 10 credits that you had. Well, if you look at this, 5 out of 10, that's equivalent to 50. And 2 out of 10, that's equivalent to 20 and 20%. And then last one, 1 out of 10 is equivalent to 10%. So what we're doing really by multiplying and then dividing by the total, you're doing the weighted average. Okay, you're dealing with percents, you just didn't know it. So that is a weighted average. Your GPA still comes out to 3.1. Okay. Now to go back to this guy, let's look at these two isotopes of lithium. So if you guys look up at the top, I've got two isotopes. One is lithium 6. That's the lighter isotope of lithium. And one is lithium 7. That's the heavier isotope of lithium. We're going to talk about what makes up lithium 6 and 7 in terms of protons and neutrons, probably in a different video. So for now, just know one weighs 6, the other weighs 7. Okay, the number in the middle right there, those are their actual masses, because it turns out lithium 6 and lithium 7, those are the mass numbers, but they don't actually weigh exactly 6 units and 7 units. Protons, neutrons, and electrons will have slightly or different masses that don't quite add up to whole numbers. But for now, we're going to simplify it, and we're just going to calculate based on their mass number. So lithium 6, let's just say it weighs 6, and really 6.01 is pretty darn close to 6. We're going to say lithium 7 has a mass of 7. Okay, and that's a pretty reasonable estimate. The final number in these columns, right, so that's the percent abundance. So it turns out when you sample the earth for the lithium and you get a representative sample of lithium, 92.41% of it is lithium 7, the heavy stuff. And the other 7.59% is lithium 6, the light stuff. So my question is, what's the average or relative atomic mass for lithium considering those two isotopes? So again, let's start with the 7.59%. So let me switch back. Lithium 6, 7.59%, and lithium 7, right? We know that it has to add up to 100% if I told you that those are the two only isotopes. So I can do this one. I think that's 92.41%. We're going to go with that. Again, the isotopes, all of them should sum to 100%, because that's you're talking about a representative sample of all the lithium on Earth. So 92.41% of it is lithium 7, and 7.59% is lithium 6. Okay, so to calculate the atomic mass, relative atomic mass, write this formula out for you. It's going to equal the mass of the isotope, and I'll say isotope number 1 times the percent abundance isotope, oops, 1, and I'll put these in parentheses, plus, I know this is a lot to write, but we're just going to get the hang of it, and then you don't have to write this. You'll just know the formula, times the percent abundance of isotope 2, plus dot 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 for all isotopes. So you're taking the mass times the percent abundance plus the next mass times the percent abundance, right? And again, order of operation says multiply first and then add together. So the mass of the isotope 1, we could go with this. We know that rounded it was about 6.01 AMUs. Okay, and the percentage was written as a decimal. So I have to move this twice when I'm writing percent to decimal form, 0.0759 plus mass isotope 2 was 7.01, and this one, move the decimal place 2 places, 0.9241 would be 92.41%. Okay, plus, I don't have anything else. There's only 2 isotopes. You could quickly see if you have more than 2 isotopes that you'd need to include those. So, but here, right, we do the multiplication first. I'll get my calculator. Maybe I'll get my calculator. There it comes. 6.01 times 0.0759, 45 point, and let's see, I had really 3 sig figs and 3 sig figs, so I'm gonna carry extra sig figs at the end and then decide what we need to do. So let's just say 45.62 plus, oops, and not 45, 0.4562, sorry, 0.4562 plus 7.01 times 0.9241, 6.478, or 477, I can say 4779 AMU. Let's add them together. So plus 0.4562 equals 6.9341 AMU. Okay, and then if I look, let's just say I've got down to the hundredths place on my masses that I knew. So I probably shouldn't report my average mass to any more precision than that. So I'm going to round off to the hundredths place. This one comes out to 6.93 AMU, which would be the relative atomic mass. Okay, remembering that one of the light isotopes was about 6, the heavy isotope was 7, and this one falls, the average relative atomic mass falls at 6.93, which is in between the two, but it's shifted closer to the heavy one. And hopefully you guys can see that's because there is more of the heavy one. Just like, let's go back to your GPA for a second. Your GPA fell close to the A-B range, I think somewhere between 4 and 3, mostly because those were the kind of the most prevalent. A was the most prevalent. However, you kind of had some B's, C's, and D's that pulled it down. And so you can kind of take a guess at where the average will fall. And for lithium, the average falls closest to the heavy isotope, right? So that's an example of an isotope with an element with 2 isotopes. I'm going to pull up isotope prevalence chart. So let's see if I can switch into Google Chrome. So you guys can see this. Isotope relative abundance by element. Oops, that's not a good link. I can do this one. Here we go. So isotope abundances. You can look, beryllium has 1 isotope, so all beryllium is beryllium 9. Boron has 2 isotopes. Carbon has two isotopes. Actually, it's got carbon 14 too. So these ones are the most prevalent. Carbon 14 is an isotope that's radioactive. So maybe these are just the stable isotopes that are listed. So two stable isotopes. Oxygen has 3. Neon has 3. Sodium, right, has 1 stable isotope. We can look over. Ooh, let's get to one that neodymium. Neodymium has 1, 2, 3, 4, 5, 6, 7. 7 stable isotopes, right? So imagine calculating the relative atomic mass for neodymium would be a lot of multiplying and adding. So you could take, I'm not going to have you do it, but take 142 and multiply by 0.272 plus 143 times 0.122 plus this times this plus this times this plus this times this plus this times this, etc. Right? Remembering when you multiply, you better use the decimal form. So move the decimal place twice. Okay? So hopefully you guys can solve that. I've got one other type of problem for you in here that I want you to see. Go to a new slide. Let's say I've got a made-up isotope. We'll call it the NF element, or Neil Ford, right? Okay, an NF isotope or element has 2 isotopes. Let's say it's got a relative atomic mass of let's say 74.5, and the 2 isotopes. So the 2 isotopes that exist are, let's say, 73 and 75. Okay, so those are the mass numbers. And the thing has a relative atomic mass of somewhere in between the two, probably closer to 75. So there's probably more 75 than 73. So what are the relative abundances? Or the natural abundances, I mean. Okay, so I want to know what percent of all this NF element are 73 and what percent are 75. So we can solve this with a little algebra. We can do it with a couple methods. We'll probably end up guessing and checking or solving it with a system of equations. But here we go. I know the 2 isotopes are 73 and 75. So if I look at my formula from the previous slide, I had said the mass number times the percent. So I could say 73 times the percent of isotope 73, plus 75 times the percent of 75 has to equal 74.5, which is the weighted average or the relative atomic mass. Okay, now we're also not used to thinking of things, right, in terms of like these weird descriptive variables. So I think you'll probably be more comfortable if I did this: 73x plus 75y equals 74.5. And then you probably could also guess that since there's only 2 isotopes, that they have to sum up to 100%. So I can write that as the percentage of 73 plus the percentage of 75 has to equal 100%. Now, all right, 100% is 1, right? So x plus y are going to be kind of the decimal percent or decimal versions of the percents. And they have to add up to 1.0, which is 100%. Okay, so I've got these 2 equations, the system of equations. You guys are used to solving this in algebra. Here's just, a little application. This is kind of a stretch of a problem. You're not going to be asked this on a test, but maybe an assignment, and just to get you guys working. So I don't know, how do you want to solve this? We could we could solve it by guess and check. You could guess an x and a y and plug them in. Like, probably not a good choice to plug in, 0.5 and 0.5, because you know that the average is going to come out to 74 if you use 0.5 and 0.5. So let me get rid of those. If you try something like, 0.1%, then y has to be 0.9%. And you could check and see if it comes out to 74.5. And they, again, x and y have to add up to 1. So you can't like cheat and use 70% of one and 70% of another, right? That's more than 100%. Or solving it algebraically, I think this is what you're used to. You want to solve it like this. So I say x equals 1.0 minus y, and I can substitute that in right here. So substituting 1 minus y in, I get 73 times 1 minus y plus 75y equals 74.5. I distribute 73 minus 73y plus 75y equals 74.5. Right? Combine those, I get 2y, 73.0, 74.5. So I can subtract 73. I get 2y equals, what is that, 1.5? Divide by 2. Y equals 0.75. Or, if y is 75%, right, that tells us the percent of 75 would be 75%. Okay, that's coincidental. And then we know that the leftover 25% has to be isotope 73. So that's one way algebraically to solve that type of problem. So again, that's kind of a stretch, but just making sure that you see that there's some kind of a point for algebra and solving problems. And hopefully this is helpful. So I'm going to leave some questions that go along. I'm going to have you analyze a sample of another made up element, the my or money element, and then try a couple more of these practice problems. So that'll be your isotope assignment for the week. So also, as you guys get questions or you're struggling with these, make sure you reach out. I'll probably do office hours, although we don't have school on Friday. So I'll try and make it a point to have office hours. I'll stay late after we're done with lecture. But please ask for clarification where needed, or start watching additional videos. YouTube is a great resource for chemistry. There's a lot of chemistry YouTubers who are publishing out content, pushing stuff to you guys, and it should be pretty easy to find. You could type in, how do you calculate relative atomic mass, and you'll probably find 500 videos just like this. Okay, so give it a shot, and good luck on the little money isotope example.